Servo motors operate differently than standard induction or synchronous motors. They need specialized controllers that provide precise control over speed, torque, and position. Servo motor and controller manufacturers use their own systems of ratings and terminology. These systems don't always align with the current provisions of National Electrical Code, NEC Article 430. To address these differences, some changes to Article 430 are needed. Firstly, consider adding a definition of a servo motor. A servo motor is specifically designed to provide precise control of speed, torque, and position. It is typically used with a specialized controller. Secondly, think about installation requirements. Servo motors and controllers must be installed according to the manufacturer's instructions. Overcurrent protection devices must be selected based on the servo motor's rated current, as specified by the manufacturer. Branch circuit conductors must be sized for the servo motor's maximum current, as specified by the manufacturer. Thirdly, let's discuss rating plates. Servo motors must have rating plates that clearly indicate the following information: 1. Rated voltage, 2. Rated current, 3. Rated speed, and 4. Rated torque. Fourthly, consider terminals. Servo motors and controllers must have clearly marked terminals that correspond to the manufacturer's wiring diagram. These additions will clarify the installation requirements for servo motors. They will help ensure they are installed safely and according to their intended use. The changes would provide a more consistent framework for rating and terminology. This will make it easier for users to understand and apply the code. Here is what to do next to submit a formal proposal for these changes. It is recommended that manufacturers or large end users contact the National Electrical Code Committee (NEC). Firstly, submit a request for information (RFI) through the NEC website app. Secondly, if the RFI is accepted, the NEC will assign a code panel to review the proposal. Thirdly, the code panel will consider the proposal, conduct any necessary research, and vote on whether to accept or reject it. Fourthly, if accepted, the proposal will be incorporated into the next edition of the NEC. The NEC addresses motor circuit protection in Article 430. It provides detailed requirements for overcurrent protection, conductor sizing, and disconnecting means for motors. When dealing with servo motors, it's important to understand how their characteristics might differ from typical induction motors, and how these differences could impact the application of Article 430. Servo motors often have unique performance characteristics. These include high starting torques or intermittent duty cycles. These characteristics need to be considered when selecting overcurrent protection and conductor sizes. Section 430.52 covers motor branch circuit, short circuit, and ground fault protection. It specifies maximum ratings or settings for overcurrent protective devices. These devices protect the motor control apparatus, and conductors against short circuits and ground faults. The type of motor and its specific application determine the appropriate overcurrent protection. Inverse time circuit breakers, instantaneous trip circuit breakers, and fuses are all used. The manufacturer's recommendations for overcurrent protection are very important. They often provide specific guidance based on the motor's design and performance characteristics. If the manufacturer's instructions are unavailable, or if the installation conditions differ from those specified by the manufacturer, it's necessary to follow the NEC guidelines for selecting overcurrent protection. These guidelines take into account the motor's full load current rating, starting current, and duty cycle. Conductors supplying servo motors must be sized to carry out the motor's full load current, as well as any additional current due to starting, intermittent operation, or other factors. Section 430.22 specifies the minimum conductor ampacity for motor circuits. It generally requires conductors to have an ampacity of not less than 125% of the motor's full load current rating. This accounts for the motor's normal operating current and any potential overloads. For servo motors with intermittent duty cycles or widely varying loads, it might be necessary to increase the conductor size beyond the minimum requirements of 430.22. This ensures that the conductors can handle the peak currents without overheating or voltage drop. It is also important to consider the ambient temperature and the number of conductors in a raceway or cable when determining the appropriate conductor size. Adjustments or corrections to the conductor ampacity might be necessary to account for these factors, as outlined in NEC Table 310.15. A disconnecting means must be provided for each motor to allow it to be isolated from the power supply for maintenance or safety purposes. Section 430.101 specifies the requirements for motor disconnecting means. The disconnecting means must be readily accessible and capable of being locked in the open position. It must have an ampere rating not less than 115% of the motor's full load current rating. This ensures that the disconnecting means can safely interrupt the motor's current under normal and overload conditions. For servo motor installations with multiple motors or controllers, it might be necessary to provide a separate disconnecting means for each motor or controller. This allows for individual components to be isolated for maintenance or troubleshooting without affecting the operation of other parts of the system. Motor control circuits, which control the operation of servo motors, must also be protected against overcurrent and short circuits. Article 430, Part Roman 7, covers motor control circuits. Control circuit conductors must be sized and protected according to their ampacity and the voltage of the circuit. Overcurrent protection devices such as fuses or circuit breakers must be selected to protect the control circuit conductors and components from damage due to overloads or short circuits. The NEC provides specific requirements for the location and type of overcurrent protection devices in motor control circuits. These requirements are designed to ensure the safety of personnel and equipment. Servo motors and controllers often incorporate electronic components and circuits. These components are sensitive to voltage fluctuations, electrical noise, and other power quality issues. It's important to provide adequate surge protection and power conditioning for servo motor installations to protect these sensitive components from damage. Surge protection devices, SPDs, can be installed at the service entrance, at the motor control panel, or at the individual servo motor or controller. These devices help to divert transient voltage surges away from sensitive equipment, protecting them from damage. Power conditioning equipment, such as line reactors or filters, can be used to reduce electrical noise and voltage fluctuations in the power supply. This can improve the performance and reliability of servo motors and controllers. Grounding is essential for the safe and effective operation of servo motors and controllers. Article 250 covers grounding and bonding requirements. Servo motors and controllers must be properly grounded to provide a low impedance path for fault currents. This helps to prevent electrical shock hazards and minimize the risk of equipment damage. Grounding conductors must be sized and installed according to the requirements of Article 250. They must be securely connected to the motor frame, controller enclosure, and other metal parts of the system. Bonding is also important to ensure that all metal parts of the system are at the same electrical potential. This helps to reduce the risk of electrical shock hazards and minimize electrical noise. The manufacturer's instructions and specifications are important for the proper installation and operation of servo motors and controllers. These instructions often provide specific guidance on wiring, grounding, overcurrent protection, and other aspects of the installation. Always follow the manufacturer's instructions carefully. Deviation from these instructions can void the warranty or create safety hazards. The manufacturer's specifications also provide important information about the motor's performance characteristics such as its full load current, starting torque, and speed range. This information is needed to select the appropriate overcurrent protection, conductor sizes, and other components for the installation. In addition to the NEC and the manufacturer's instructions, other applicable codes and standards might apply to servo motor installations. These codes and standards could include local building codes, fire codes, and safety standards. Be familiar with all applicable codes and standards. Comply with them during the design and installation of servo motor systems. Regular inspection and maintenance are essential for the safe and reliable operation of servo motor systems. Inspections should be performed to check for any signs of damage, wear, or corrosion. Maintenance should be performed to lubricate moving parts, tighten connections, and replace worn components. Keep records of all inspections and maintenance activities. This can help track the performance of the system and identify potential problems before they become serious. When troubleshooting servo motor systems, it's important to have a systematic approach. Start by checking the power supply, control circuits, and wiring connections. Use a multimeter or other test equipment to verify voltages, currents, and resistances. Consult the manufacturer's troubleshooting guide for specific guidance on diagnosing and repairing problems. If the problem cannot be resolved, contact a qualified electrician or servo motor technician for assistance. Several types of servo motors exist. These include alternating current (AC) servo motors and direct current (DC) servo motors. AC servo motors are commonly used in industrial applications. They offer high performance, reliability, and efficiency. DC servo motors are often used in smaller applications. They provide precise control and responsiveness. The selection of the appropriate servo motor depends on the specific application requirements, such as the required torque, speed, and accuracy. Servo motor controllers are used to control the speed, position, and torque of servo motors. These controllers use feedback signals from the motor to precisely control its operation. Servo motor controllers can be either analog or digital. Digital controllers offer greater flexibility in control. Servo motor encoders provide feedback signals to the controller. These signals indicate the motor's position, speed, and direction. Encoders can be either incremental or absolute. Absolute encoders provide a unique position signal for each position of the motor shaft. This allows the controller to determine the motor's exact position at any time. Servo motor brakes are used to hold the motor in a fixed position when it is not powered. Brakes are typically used in applications where the motor must maintain a constant position, such as in robotic arms or machine tools. Servo motor gearboxes are used to increase the motor's torque or reduce its speed. Gearboxes are often used in applications where the motor needs to drive a heavy load or operate at a low speed. Servo motor couplings are used to connect the motor shaft to the load. Couplings must be able to transmit torque without introducing any backlash or vibration. Servo motor cables are used to connect the motor to the controller. Cables must be shielded to prevent electrical noise from interfering with the motor's operation. Servo motor filters are used to reduce electrical noise and improve the performance of the motor. Filters are typically installed on the motor's power and signal lines. Servo motor software is used to program and configure the motor controller. The software allows users to set parameters such as the motor's speed, position, and torque limits. Servo motor tuning is the process of adjusting the controller's parameters to optimize the motor's performance. Tuning is typically performed using specialized software and test equipment. Servo motor diagnostics are used to identify and troubleshoot problems with the motor and controller. Diagnostics can be performed using the controller's built-in diagnostics tools or with specialized test equipment. Servo motors are used in a wide variety of applications. These include robotics, machine tools, packaging machinery, and printing presses. They provide precise and reliable motion control for these applications. Servo motor technology is constantly evolving. New types of motors, controllers, and encoders are being developed all the time. These advancements are improving the performance, efficiency, and reliability of servo motor systems. The NEC addresses several aspects of motor installations. This includes locked rotor amps, which is the current drawn by a motor when it is initially energized but the rotor is not yet turning. It's a critical parameter for sizing overcurrent protection devices. The NEC provides guidelines for determining the locked rotor current of motors based on their horsepower and voltage ratings. This information is used to select fuses or circuit breakers that can withstand the high inrush current without tripping unnecessarily. The NEC also addresses the issue of motor heating. Motors generate heat as they operate, and excessive heat can damage the motor windings and insulation. The NEC specifies maximum allowable temperature rises for motors based on their insulation class and ambient temperature. It also requires that motors be installed in locations that provide adequate ventilation to dissipate heat. The NEC also addresses the use of motor starters. Motor starters are devices that are used to safely start and stop motors. They can also provide overload protection and other control functions. The NEC specifies the requirements for motor starters based on the motor's horsepower and voltage ratings. It also requires that motor starters be properly grounded and protected against short circuits and ground faults. The NEC also addresses the use of variable frequency drives, VFDs, for controlling the speed of motors. VFD are electronic devices that can vary the frequency and voltage supplied to a motor. This allows for precise control of the motor's speed and torque. The NEC specifies the requirements for VFD installations. This includes grounding, wiring, and overcurrent protection.